because this whole packet is a quiz. All right, so first thing I need to do is I need to move 9 over to the other side. How do I do that? Add it. Perfect. So first I'm going to add 9 to the other side. Is there anything to combine it with? No, and since it's a constant, it goes at the end. So you should have gotten 2x squared plus 9x plus 9 equals 0. Who got that far? Give me a thumbs up. Beautiful. Then we label our A, B, and C. So our A is 2, our B is 9, and our C is 9. We can also see that there's no number that goes into all 3 of them besides 1. So then I'm going to find my vertex first, since that's what we did yesterday. And so remember, the vertex formula is the outside of that quadratic formula, which was negative b over 2a. I'm never going to give you that formula. I'm not going to provide you with that, but you know it's the outside of your quadratic formula, which I do provide you with. Yeah. The vertex? Oh, you're getting the roots. That's, I could do it that way too. But the vertex is negative b over 2a. The roots I could have used quadratic formula or factored and made them equal to 0. So when I do this, I end up getting negative b, so the opposite of 9 is negative 9, over 2, and my a is 2, which you should have gotten negative 9 over 4. So you could have left it like that, or did negative 2.25. And so I know that that is my axis of symmetry, so I know x equals negative 2.25. I also know it's my x coordinate of my vertex. So this, if you typed it into that table, it wouldn't have showed up because it is a decimal. So you do need to know this way for that reason also. Then to get my y coordinate, I just plug it back in. So I write the original equation, but instead of x, I'm going to plug in negative 2.25. And you could use a calculator for this one, just because it is a decimal. You still should be able to figure it out by hand. But when you put that in the calculator, you end up getting negative 1.125. Equals y, and so I know that's my y coordinate. And so that would be my vertex. And so we learned how to do it in the calculator. And if you have a graphing calculator, you could actually look at the graph and trace it on your calculator and find that that was the vertex also. But this is the algebraic way to do it. Does that make sense? So that's what we learned yesterday. Roots, you could have factored, you could have used quadratic formula. Either way, you get the same answer. So there's a lot of factoring on your test, so I'm going to go over that. So first we see, is there anything to divide out? Nope. So I get started with my x. And remember, what is 8 times c, 2 times 9? 18. And it has to add to my b at the bottom, which is 9. And so there is a lot of this on your test, a lot of factoring. So it's a lot of like, give me the factors, where you don't have to equal them to 0, it's just the factors. So you need to know how to do this way. What two numbers multiplied as 18 add to 9?
36.
36. Ding, ding, ding. And so you should have at least gotten x plus 3, if you did it this way, x plus 6. That will be an answer choice on your test. But what is my a here? 2. So you need to put 2 under both of them and reduce. So can this one reduce? No, so I put the 2 in the front, so the factor would be 2x plus 3. Can this one reduce? What does that reduce to? 3. So those would be my factors. Now, when I'm doing it this way, my roots, if they're just asking for the roots, you don't need to do all the factors and everything like that, because that's actually more work. I just look at this and I go, okay, what's the opposite of 3 over 2? What's the opposite sign? Negative 3 over 2. That's my first root. If I were to make that equal to 0 and solve, you would have gotten the same thing. Or negative 1.5. What about here? What's the opposite of 3? And those are your 2 roots. That's technically what you're doing when you make your roots equal to 0. So if I were to make these 2 equal to 0 and solve, those are what I would have gotten. Does that make sense? thing is your y-intercept, so you could have either plugged in 0 for x and solved, or you know it's always your constant. What is my constant here? 9. So that's always your y-intercept, so 0, 9. Or if you plug 0 in, 0 squared is 0, times 0 is 0, plus anything times 0 is 0, plus 9 is 9. Either way. So, write how you, make sure you have this down, because this is going to be a good study tool for you when you're looking and you're trying to remember how to do these things. That's why I have you do this as part of the quiz grade, because this is like a little study guide. So circle how you feel about this. Maybe means like I knew how to do the roots and vertex, and maybe I forgot how to do the y-intercept. No means like I didn't even know where to start. Yes means like you got this all right. So circle, like assess how you felt like you did on this too now. Because that's just combining what we've been doing. If you did quadratic formula for this, negative b, that whole equation, you should have gotten the same answers as well. Cool. So this lesson's pretty easy today. This is our last lesson, so make sure you put those devices away. Make sure you put those computers in courtesy mode, so you can just put it in a little angle. And we're going to be going over our notes for today. So these are our last set of notes. I'm pretty sure we might have ones on Monday, but this is our last really new material that we're going to be learning. And so when we look at this, we notice that all of these have something in common. It's when there's no middle term. So we use this method, it's called by taking the square roots. We use this method when there is no middle term, or no b. So like when we have y equals ax squared, like in standard form, plus bx plus c, there's no middle term, there's nothing attached to x. That's when we use this method. So we can see none of these have like a number with just x attached to it. And so all we're doing, it's like a two-step, multi-step equation, is solving for x. And this gets you your roots. This gets you your x-intercepts. And so we're just moving it around to get x by itself. So first, I want to get 180 to the other side. How would I do that? Add it. So I'm going to rewrite the problem just a little bigger. And I'm going to add 180 to both sides. What is 0 plus 180? Good. So it should look something like this. So this is the easiest way because it's literally like a two-step equation. Then how do I get rid of that 5? Divide it, right? And you end up getting x squared equals 36. Lastly, how do I get rid of a square? Square rooted. Now this is important because this is where we make errors a lot. When we take this square root, we get 2 answers. Even though you put it in your calculator and you'll get 1 answer, there's actually 2 answers. It's always the positive and the negative. Like if you put square root of 36, you would just get 6. But it's actually both 6 and negative 6. That's because the square root of 36, even though 6 comes up in your calculator, negative 6 is also the square root of 36. Because if I multiply negative 6 times itself, what is negative 6 times negative 6? Positive 36. So these are both your answers. That's why when we do the quadratic formula, you know that plus and minus thing? That's why that's a plus and minus, is because the square root is technically a positive and negative. So that's why we have that little thing. So your roots here would be 6, 0 and negative 6, 0. That's it. So you're basically undoing each thing to get x by itself. So right here you could see, okay, I want to get x by itself. How do I get rid of 4? Divide by 4. And I don't want you to divide by 4 yet. Notice that this fraction, there's something with the numbers, like a pattern that we can recognize. What's different about those two numbers when I'm looking at them. 81 and 4, what type of numbers are they? Anyone know? I'll give you do you hear them? They're perfect squares, and you don't get a decimal. You gotta take the square root of them. So these are perfect squares. So I would keep it like a fraction, and I would take the square root of both sides. When I do that, what is the square root of 9, or square root of 81? 9 and negative 9. And square root of 4? 2. So my two answers would be, and you can write it as a decimal, 4.5, comma 0, negative 4.5, comma 0. And so sometimes I know on the EOC for sure, they will have these where you have to take the square root, and you notice that there is a perfect square, and that's how it's done. All right, last one over here. I look right here and I see, okay, what can I do first? I can't touch this square until I get rid of that 4. How would I get rid of that 4 in the front? But that would be like not getting rid of it, right? What's the opposite of distributing? Dividing. We need to divide. We want to get rid of it on both sides. If I distribute it, it would just keep it on that side. So when I do that, you would get x minus 5 squared equals 9 over 4. I would keep it that way because I notice that they're both perfect squares. Because the next thing I'm going to do is take the square root. If they aren't perfect squares, then just divide. Then I take the square root because I can't touch what's inside until I get rid of the square. So I take the square root of both sides. I end up getting x minus 5, but I'm going to get 2 different answers. So I'm going to put it twice. And so what is the square root of 9? 3. What's the square root of 4? What is 3 divided by 2? What's a decimal? 1.5. So we're going to put 1.5 right here, and then negative 1.5 right here. Remember, it's the positive and the negative answer. So I took what was inside the parentheses, and I took the square root, but I wrote this twice because when I take the square root of that, I'm going to have 2 answers, the positive and the negative.
You square root of 2, right?
Which one?
You square root of 2.
No, you don't. The answer, the square root of 9 over 4 is 3 over 2, which is 1.5. If you could leave it as 3 over 2, but then you would have to add 5 to both sides. Because you get it by itself.
Still got 3.2.
Do that little arrow thing. Remember, if you want to get it to a decimal, do the little arrow thing. When I add 5 to both sides, you'll end up getting x equals 6.5 and x equals 3.5.
You gotta add 5 to both sides.
Yep, because it's still just x minus 5 in the parentheses. And so these would be your 2x and your 10. 6.5, comma 0, and 3.5, comma 0. Does that make sense? Awesome. So you could go ahead and put that in your notebook. I have tape that you can use too, so you can pass that around if you need the tape because we're out of glue. So I'll pass around the tape if you need it. And then we're just going to practice with this. We're going to do a little game with it too, just change things up. But I want to make sure we got this down first. So we're going to go, I'm going to do like a few with you on this worksheet, which is just like a drilling hill. And then we're going to play a little game. Does everyone have this down? Make sure you've got that down. I'm going to stop recording. Does everyone get when we would use it?